Scientists may have just found evidence of a hidden planet in our own solar system. Not beyond distant stars, not in another galaxy. Right here, orbiting the Sun. For years, astronomers have been noticing something strange happening far beyond Neptune. Objects in the outer solar system were moving in ways that didn't quite make sense. Their orbits were stretched, tilted, and oddly aligned, as if something massive was pulling on them. Now, new studies suggest there may be a large, unseen planet hiding in the darkness. A world so distant and faint that telescopes have struggled to detect it directly. Some scientists call it Planet 9. Others still refer to it as Planet X. And if it exists, it could be one of the biggest discoveries in modern astronomy. To understand where this idea comes from, we need to look at the outer edge of the solar system. Beyond Neptune lies a vast region filled with icy objects, known as the Kuiper Belt. This area contains dwarf planets like Pluto, along with thousands of smaller bodies left over from the early formation of the solar system. Most of these objects follow predictable orbits around the Sun. But over time, astronomers began to notice that some of them behaved very differently. Several distant objects had highly elongated orbits that all pointed in roughly the same direction. Instead of being randomly distributed, their paths appeared clustered, almost as if something was guiding them. That was the first clue. In 2016, astronomers analyzing these unusual orbits proposed a possible explanation. They suggested that a large, unseen planet might be influencing these objects through gravity. According to their models, this hidden world could be about 5 to 10 times more massive than Earth. It might orbit the Sun at a distance of hundreds of astronomical units, meaning hundreds of times farther from the Sun than Earth. At that distance, one full orbit could take anywhere from 10,000 to 20,000 years. That would make it incredibly difficult to detect. Even large telescopes struggle to see objects that faint and distant. The planet would reflect very little sunlight, and it would move extremely slowly across the sky. But here's where things get more interesting. As more distant objects have been discovered, the pattern has continued. Additional trans-Neptunian objects show similar orbital clustering, strengthening the idea that something massive could be shaping their motion. Computer simulations have shown that a planet with the predicted mass and orbit could produce exactly this kind of effect. In other words, even though astronomers haven't directly seen Planet X, they may already be seeing its influence. There is another reason why this planet could have remained hidden for so long. Some models suggest that its orbit might be highly tilted compared to the rest of the solar system. Instead of orbiting neatly along the same flat plane as the planets, it could move at a steep angle, spending most of its time far above or below where astronomers typically search. It may also currently be located in a region of the sky that is difficult to observe, possibly hidden behind dense star fields or simply too faint to stand out. Because of this, scientists have been conducting targeted searches using powerful telescopes, scanning large sections of the sky over many years. So far, no direct image of Planet X has been confirmed, but the evidence continues to build. There are also alternative explanations. Some researchers argue that the strange orbits of distant objects could be caused by observational bias. Because astronomers tend to search certain regions of the sky more than others, the data might appear clustered, even if it is not. Others suggest that the combined gravitational influence of many smaller objects could create similar patterns. There is even a hypothesis that a past stellar encounter, when another star passed near our solar system millions of years ago, could have disturbed these orbits. But none of these explanations fully account for all the observed data. That is why the Planet X hypothesis remains one of the leading ideas, and the search is accelerating. New telescopes, including next-generation survey instruments, are expected to scan the sky with greater sensitivity than ever before. These surveys may finally be able to detect faint objects moving slowly in the distant solar system. If Planet X is real, astronomers believe it could be found within the next decade. And if it is discovered, it would reshape our understanding of how the solar system formed. Some theories suggest that this planet may have formed closer to the Sun and was later pushed outward by gravitational interactions with Jupiter and Saturn early in the solar system's history. Other ideas propose that it could even be a captured object from another star system. Either way, it would represent a completely new class of planet in our solar system. Right now, the outer solar system remains one of the least explored regions around us. We have mapped the surfaces of Mars and sent probes beyond Pluto, but vast areas of space around the Sun are still largely unknown. And somewhere out there, far beyond Neptune, a massive world could be moving slowly through the darkness, hidden from view. If scientists are right, Planet X has been there the entire time. We just didn't know where to look.
So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the fifth largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet. So, what is the habitable zone? Well, in my room, it's the small section which isn't buried in food wrappings and video games. But astronomically speaking, it's a region around a star where the temperature of H2O matters. Too hot and the water will evaporate. Too cold and it will freeze. So just like Goldilocks, the habitable zone is just right to allow liquid water to exist. And water is essential for life as we know it. Just ask the three bears. The size of this zone depends on the temperature of the star, but the habitable zone isn't necessarily a guaranteed oasis of life. Other factors, such as a planet's atmosphere and magnetic field, also play a crucial role in this. Scientists have discovered more than 5,000 planets outside our solar system, and only 63 of them are potentially habitable for life forms like on Earth. Kind of a cosmic lottery. The good news is, this rule also works for the moons. If moons of planets are within the habitable zone, they may also have conditions suitable for life. That would be a jackpot in our lottery, 2 oases for the price of 1. In our solar system, this zone is within a range of 80 to 111 million miles. Of all the planets, only we were lucky enough to have life. But what if we could make all the planets in our solar system habitable? Well, let's start with Mercury. First off, we'd need to give Mercury a bit of a makeover by thickening its atmosphere and providing it with a magnetic field. So let's shower it with some asteroids that contain water. It's terraforming time, baby! Mercury is the closest planet to the Sun, which means it gets plenty of sunshine. So, not that it needs any help in that department. Actually, Mercury needs to chill out a bit. Right now, it's 800 degrees Fahrenheit. That's too hot, said Papa Bear. That's why we should move it to a more habitable orbit, about twice as far away from the Sun as it is now. Now, thanks to terraforming and pleasant temperatures, we'd finally get some water. And if we want to get really cozy, we could always build habitats underground or on the surface, but then we'd have to shield them from the heat and radiation. Anyway, with a little creativity, we could make it work. I mean, people live in Arizona, right? Yeah, but then we'd need a lot of golf courses. Let's move on to Venus. The famous planet of love, where the temperatures are hot enough to melt lead and the atmospheric pressure can crush you in seconds. Isn't it romantic? Venus is referred to as Earth's sister planet, but as it often happens with siblings, we have almost nothing in common. Well, let's try to solve this problem. If we add some hydrogen on Venus, it could react with the carbon dioxide in the atmosphere to form water and graphite. Water would help us to create some oxygen, but for this plan to work, we'd need to get hydrogen from space like it's a Black Friday sale. After that, we can build our new homes. We'll just have to make sure the buildings are strong enough to withstand the winds and acid rain. Piece of cake, right? Luckily, with the next planet, things are much easier. Mars is often considered the most promising candidate for extraterrestrial life in our solar system. It's a rocky planet with a thin atmosphere, but it has signs of water on its surface. And not only water, but even microbial life. So, the Martians must think of us as extraterrestrials. Anyway, if we're going to terraform Mars, adding oceans is a must. They'd thicken the atmosphere and warm the surface. Time for another asteroid shower. Or we could create some giant mirrors to reflect the sunlight and melt the ice caps. Easy peasy. And as soon as oceans appear on Mars, it'll gradually turn into a lush green planet, very similar to our Earth. After that, we'll just need to build some artificial habitats and make sure they have all the comforts of home. Now, making rocky planets habitable isn't that difficult compared to the gas giants. Jupiter has no solid surface at all, and it's basically impossible to colonize. So let's get creative. We could build floating habitats in the clouds of Jupiter, where temperatures and pressures are more Earth-like. We just need to protect them from little inconveniences, like wind speeds of more than 400 miles per hour and lightning every other minute. But if we manage to build homes in Jupiter's atmosphere, we could have some truly unique views. Just imagine waking up every day and seeing swirling clouds and colorful bands out your window, or taking a stroll through the gas giant's thick atmosphere. Scary and awesome. Just watch your step on that balcony. We could also use some high technologies to make Jupiter's atmosphere breathable, something that would consume its gases and release oxygen. Now, this is pure sci-fi, but wouldn't that be cool? Let's move on to Saturn. It's also a gas giant which has no solid surface for life to exist. But don't lose hope. Just like with Jupiter, we could create some floating habitats in the upper atmosphere of Saturn. Try living on a luxurious cloud, although the rent would be sky high. We could also cover the planet with a giant shield, like a cosmic umbrella. In space, it's raining cosmic rays instead of water. But this barrier could protect us from harmful radiation and solar winds. Thanks to this, the weather on Saturn would become a bit calmer. Also, remember how we were talking about moons? One of Saturn's moons, Titan, has a dense atmosphere and maybe even a subsurface ocean of water. Enceladus also hides an ocean beneath its crust. Both of them might be perfect places for actual colonization. That would be much easier than colonizing Saturn. Uranus is another ice giant made up of dense fluid icy materials, methane, ammonia, and water. Considering the surface temperature of minus 353 degrees Fahrenheit, you could say it's pretty chilly out there. So how do we make this work? Well, we could try to create a greenhouse effect. It's a natural process that helps keep the Earth's temperature stable and pleasant, unless we mess around with it. When sunlight enters the Earth's atmosphere, some of it gets trapped by gases called greenhouse gases. They act like a blanket around the Earth, keeping the planet warm, unless we mess around with it. So, if we want to make this ice giant warmer, we can try to recreate this effect, only better. For example, we could introduce some of these gases into Uranus's atmosphere, or build a network of mirrors to trap the heat from the sun. Although it would require tons of giant mirrors, and just imagine trying to position them all correctly. So, instead of all this headache, we could always set our sights on Uranus's moons. They're believed to have rocky surfaces and maybe even oceans that could support life. Plus, the views are out of this world. Moving on to the final planet, Neptune, the cool, distant cousin of the solar system. It's also an ice giant. Its year lasts 165 Earth years. Now first, let's create an atmosphere. Neptune's atmosphere is mostly made up of hydrogen, helium, and methane. Phew. We need to transport some plants there, or simply lots of oxygen to make this place a bit more breathable. And how do we add water to a gas giant? Maybe by melting ice from the moons, or by transporting large amounts of water from Earth. Just imagine a squadron of spaceships dragging giant containers to Neptune. And then, once the planet has a breathable atmosphere and liquid water, we'd need to build habitats. Probably another sky city, because you can never have enough of those. So let's say we somehow magically made all the planets habitable. Now what? Well, there would be a boost in human exploration and colonization. People would build new homes on different planets. Imagine immigrating from Mercury to Neptune because you prefer chilly temperatures more. With more habitable planets to study and explore, scientists would learn more about our world. We'd have so many breakthroughs. Also, it's time for some interplanetary trade. We could mine tons of resources from planets, asteroids, and moons. A dream come true for Elon Musk. But of course, it's not all fun and games. All of this would most likely lead to conflicts over resources and territory. Imagine trying to keep peace between Jupiterians and Martians. Well, all jokes aside, the possibility of all planets being habitable is mind-boggling. But in reality, terraforming planets like this is impossible, at least for now. But who knows? Many things were considered impossible before, but this didn't stop us. So, let's keep dreaming. Meanwhile, we can clean up the planet we're already on.
Have you ever thought about Earth itself as an intelligent, well, not creature, but maybe an entity? Like it has a mind and some survival instincts of its own. When said like this, it sounds like you're about to watch a fantasy movie where the planet we walk and live our daily lives on will suddenly wake up, realize it doesn't like us that much after all, and just go crazy. Hope not. But we're not actually talking about such scenarios. More of the idea that the collective activity of life, like microbes and plants, can change a planet and give it a life of its own. It's like the planet has a green mind. The metaphor of Earth as a living planet makes sense. Creatures across the globe crawl, swim, walk, and fly through the uppermost layers of our land, ocean, and sky. Plants cover much of our world. Plus, there are viruses and bacteria in the water, soil, and even atmosphere. Now imagine all the living things on Earth, like plants, animals, and microbes, as a giant team working together. They have different jobs, but they all do their thing to make the planet a better place to live. For example, plants make oxygen that we breathe, and animals help pollinate flowers. Together, they form the biosphere, which is like the Earth's team of life. That's where the idea of planetary intelligence comes in. Just like individuals and groups can be intelligent, so can an entire planet. Researchers believe we should measure the planet's intelligence by its ability to keep itself going forever. And just like how humans need to work together to survive, a planet's collective intelligence is measured by the capacity of all the life on it to work together towards this same goal. It's like the planet is a complex system that knows how to take care of itself. Like forests. They can share nutrients through their secret underground networks of fungi. This helps all the trees stay healthy. You can obviously learn a lot from forests. If we jump into the fantasy universe while looking for intelligent, conscious planets, we'd definitely choose Mogo from Green Lantern. It's a specific planetary entity that can do things like changing its weather and altering gravity, plant growth, or some other surface conditions. Or how about the stunning Pandora from Avatar? Do you remember the fascinating scenes of flora and fauna there? With organs that might remind you of tentacles. They enable creatures to interlink with each other on a neural level. It's like the entire planet is like one giant brain, with many smaller trees, creatures, and its other pieces as its cells. We're far from that, but it's still nice to imagine. At the moment, our civilization is in the stage scientists named an immature technosphere. That means we're still too focused on using technology that doesn't always do good for our planet. We don't have a planetary intelligence or a collective understanding of what needs to be done to do better for our planet. Instead, we're all just doing our own thing. I mean, we're not at the worst stage. Researchers have come up with 4 stages of Earth's past and future to explain how planetary intelligence could impact the long-term future of humanity. The first stage is what we call the immature biosphere. It's when life first started on Earth, billions of years ago. Only microbes were there on the bare land without any vegetation. There wasn't any global feedback, which means these microbes couldn't yet affect Earth, its atmosphere, or other systems in any way. The second stage is the mature biosphere, which was 2.5 billion to 540 million years ago, when stable continents formed and the biosphere started to have a strong influence on the Earth. The third stage, known as immature technosphere, is where we are now, with interlinked systems of communication, technology, transportation, electricity, and computers that draw resources from Earth's systems and affect the biosphere. The fourth stage, also known as the mature technosphere, is where Earth should aim to be in the future. It means technology will benefit the entire planet. We'll use sustainable forms of energy, like solar power. Planetary intelligence is the sign of a mature planet, and researchers are trying to figure out how we can move towards it. So things we do on an individual level do matter. The collective activity of life, like microbes or plants, can change a planet and make it more than just a lifeless rock floating in space. Through the biosphere, our home planet kind of figured out how to host life by itself billions of years ago, and it's still going. Now we need to figure out how to have a similar kind of self-maintaining system, but this time with the technosphere. It's hard to imagine planets could generally become sentient, like Pandora, or some other imaginary conscious world out there. There are a few reasons for that. First, planets form based on how different materials, like rocks, gases, and liquids gather around a new star. It's like you have a big family gathering, where everyone brings different ingredients to make a delicious dish. And just like how these ingredients won't suddenly turn into a living being, the materials that make up a planet won't just turn into self-aware creatures. On Earth, after billions of years of complex chemical reactions, some molecules started to replicate themselves and carry information. That's how life on our planet began. And Earth is the only such example we have. Here's the second reason. Imagine you have a big garden where you plant a lot of mushrooms or bacteria, hoping they'll become really smart and help you take care of the garden. But mushrooms and bacteria don't have brains like we do. It's not like they need it anyway. Having a big brain is really expensive for animals too. It takes a lot of energy to keep it running. So, animals only become as smart as they need to be to survive and thrive in their environment. Dogs and cats are pretty smart because they need to be able to avoid danger and find food. They don't need human kind of intelligence for things like building houses, creating art, or inventing new technologies. So it would be hard to bring all living beings and plants to the same level of intelligence. The third reason why it would be difficult for a planet to become sentient is the main rule of the animal kingdom. Life is all about survival of the fittest. Every creature is competing for resources like water, food, and space. But not only do different species compete against each other, but individuals within the same species also fight. Just think of how fiddler crabs fight for territory on the beach, or how wolf packs fight over prey. Or me, when I see an empty spot on a crowded beach. This kind of competition is not a good base for global cooperation. There are a couple of exceptions to this rule. For example, ants. They may not be the brightest creatures on the planet, but when they come together in colonies, they can achieve amazing things, like gathering food that's way bigger than them, building nests, raising young, and even farming. In fact, they act like a superorganism called a hive mind, where every ant works together towards a common goal. Insects like bees and ants are very altruistic and work together to ensure their queen reproduces. If one large ant colony took over our whole planet, it could act as a single mind and work towards the colony's and planet's interests until they run out of resources. But in reality, it's hard to imagine any organism, even a superorganism, could reach such a level of self-awareness and consciousness. Number 5. How could we keep in contact? When it comes to communication, ants use pheromones and humans use nerves. Both of these methods work well for small organisms, but when it comes to a giant planet-sized entity, it would be hard to make such communication fast and efficient. So, communication within a planet-sized entity would be much slower than what we have in our homes, like our computers or smartphones. Oh well, we'll just continue dreaming about Pandora.
As scientists continue to explore the vast expanse of the universe, they've made some incredible discoveries that have left them with more questions than answers. From a scorching super-Earth to a football-shaped world, the exoplanet discoveries of 2022 are truly out of this world. So, hold on tight, the future of exoplanet discoveries is looking brighter than ever. Number 1. New type of exoplanets. Red dwarfs make up over 70% of all stars in space. So, in September of 2022, scientists decided to take a closer look at the small worlds orbiting them. What they found was amazing. New type of exoplanets that were made of half rock and half water, either in liquid or ice form. The researchers suggested that these planets likely arose from icy material and were born far away from their stars, past the ice line, where surface temperatures are freezing. But they later migrated closer in, to where the astronomers detected them. This discovery could have huge implications in the search for life in the cosmos. Though these planets are loaded with water, they might not be covered in oceans. Who knows? Maybe one of them will be the next Earth 2.0. Number 2. Jupiter-sized world. Imagine a planet so massive and mysterious, it's like a hidden Jupiter in our galaxy. Well, we just discovered one of those orbiting a star just 379 light-years away. Just. We've named it the TOI 2180b, and it's got everyone talking. Why? Well, for starters, this planet takes a whopping 261 days to orbit its star, which is much longer than most distant gas giants we've come across so far. But that's not all. The temperature on this world is surprisingly mild, averaging at a balmy 170 degrees Fahrenheit. For comparison, the temperature on Jupiter and Saturn is around minus 280 degrees. It's like a bridge between the giant exoplanets we've found and our Jupiter. But the question remains, how did this planet get to be so different? Scientists are still trying to figure that out. Let's hope that we get some answers soon. Number 3. The Hulk planet. This world is a place where the surface is covered in molten magma, and the year lasts just half a day. Welcome to TOI 1075b, an exoplanet that's been dubbed the planet Hulk by scientists. Located 200 light-years away, this super-Earth is one of the most massive ever discovered. Its proximity to its parent star causes its surface to reach scorching temperatures of 1922 degrees. It's so hot that any form of water would evaporate instantly, and the air would be filled with vaporized rock. But it's not just the heat that's impressive, it's also its size. TOI 1075b is nearly 10 times the mass of Earth, making it one of the most massive super-Earths ever discovered. But the mystery doesn't stop there. The planet's orbit takes just 14.5 hours, making it one of the shortest orbital periods ever recorded for a planet of its size. What an exciting addition to our catalog! Number 4. 3 doomed planets. Astronomers made a shocking discovery of 3 planets that are circling in a dangerous dance next to the slowly fading stars. Just a decade ago, scientists never even imagined such planets could exist. These gas giant planets, similar in size to Jupiter, orbit way too close to their slowly fading stars. They're basically walking on the edge. Take one of them, for example, dubbed TOI 2337b. Its orbit will likely send it hurtling straight into the fiery arms of its host star in less than 1 million years. Well, I won't be around then. As these stars enter their final days, they're pulling in nearby planets like a black hole, altering their orbits and potentially causing catastrophic collisions. And as these planets get closer to their stars, their atmospheres heat up and swell, leading to some mind-boggling differences in density. But despite the doom and gloom, studying these worlds could give us valuable insights into the evolution of our own solar system. Number 5. Planet with a barium's atmosphere. These are 2 hot blazing planets, each with an atmosphere made of the heaviest element ever found in an exoplanet, barium. These planets, known as WASP-76b and WASP-121b, are ultra-hot gas giants called super-Jupiters that orbit incredibly close to their stars. These planets are basically like giant balls of fire, with one side facing the star, cooking at temperatures hot enough to vaporize iron and other metals. But as the hot iron vapor is blown into the planet's cooler night side, it turns into liquid and falls as iron rain. And these planets held a special surprise for us. Barium is a heavy metal, about 2.5 times as heavy as iron. And yet, scientists were able to detect it in the upper layers of these planets' atmospheres. This is truly a mystery, and a puzzle we're still trying to solve. Imagine landing on a planet like this and looking at this rain of iron and the heavy barium in its skies. That would be awesomely horrifying. Number 6. The Football Planet. Get ready to have your mind blown, space enthusiasts, because we've just discovered the ultimate football-shaped planet. and it's unlike anything we've ever seen before. Meet WASP 103b, the ultra-hot exoplanet that's more than 1,000 light-years away from Earth. This gas giant is so close to its parent star that its shape is being stretched by the intense gravitational forces. But this isn't just a fun shapeshifter, it's also a valuable scientific discovery. By studying the planet's passes across its star, we were able to measure its deformation for the first time ever. It's like taking a snapshot of a planet in motion, and it's giving us insights into the extreme conditions that these planets can endure. This is truly a great discovery. Number 7. A zodiacal light. Are you ready for a cosmic ghost story? Scientists and high school students in China have uncovered a spooky phenomenon on 3 distant exoplanets. It's called zodiacal light, a glow that's similar to the one seen here on Earth during sunset. But this isn't just some eerie light show. It could hold clues about the makeup of these potentially habitable worlds. Imagine watching the sunset from a dark spot on Earth, and instead of darkness, a triangle of light appears. That's zodiacal light. It's caused by sunlight reflecting off dust particles that fill the solar system, the remains of asteroids and comets. A team of researchers analyzed 47 potential habitable exoplanets named Kepler 69c, Kepler 1229b, and Kepler 395c, all super-Earths, had signs of this light. This discovery is more than just a spooky phenomenon. It could reveal information about the presence of asteroids and comets in these exoplanet systems, which could be difficult to detect otherwise. So that's pretty neat. Number 8. A planet with silicate clouds. Introducing VHS 1259b, not a home video recording system, but a strange and exotic world shrouded in mystery and wonder. A place where the clouds are made of sand and the sky is forever red. This isn't the stuff of science fiction, but a real-life discovery made by the brilliant minds at NASA. This is a brown dwarf exoplanet that's making waves in the astronomical community. It's way too massive for a planet, nearly 20 times the size of Jupiter, but it's not quite a star. It's something in between, a cosmic enigma that defies definition. But what's really crazy about VHS 1256b is its atmosphere. Scientists have discovered that this strange world is cloaked in thick clouds of silicate grains, similar to sand. It's the first time this kind of cloud has ever been detected on an exoplanet, and it's a discovery that's sure to change the way we think about the universe and the possibilities of life beyond our world. And there you have it, folks. The year 2022 was filled with incredible discoveries and groundbreaking findings in the world of exoplanets. But this is just the beginning, as scientists and researchers continue to explore the vast expanse of space. We can only imagine what other wonders await us. So, let's keep looking. Who knows what secrets the stars hold for us next?
The infinite vasts of the universe hold endless possibilities and secrets. And here's one of the intriguing questions: how life and we as humans would look like on other planets. Imagine a world where the laws of physics, the environment, and the conditions are vastly different from what we're used to. How would we adapt and evolve to survive in these strange new lands? Let's see. Mercury is the closest planet to the Sun and has a thin atmosphere. The temperatures there are extreme, with the day side reaching over 800 degrees Fahrenheit and the night side dropping to negative 290 degrees Fahrenheit. So, what can we do to survive these crazy temperatures and constant solar radiation? Maybe we can magically turn into metal. For example, titanium and platinum can perfectly tolerate high temperatures. But seriously though, there is an option. We could settle underground, where the temperatures aren't so frenzied. If we lived underground, we might evolve with large eyes to better capture light. We might also evolve thicker skin to protect ourselves from the intense radiation. Basically, we have two options: become metal or become moles. Let's move on to Venus. This planet is extremely hostile. First of all, Venus is known for its thick, more toxic than your ex type of atmosphere. The whole planet is covered with carbon dioxide, and its surface is absolutely dry, making it incredibly hot. The average temperature is around 847 degrees Fahrenheit, making it one of the hottest planets in our solar system. Also, don't forget about the crazy pressure. Standing on Venus would be like standing 3,000 feet underwater. Only particular hardy microbes from Earth could survive in such conditions. So, if you want to live on Venus, you might have to become a microbe. But unfortunately, since we're not microbes, we have to wear special gear and equipment to survive there. Maybe we'd have to develop a heat-resistant exoskeleton to protect ourselves, as well as get some new lungs that can filter out the toxic elements in the atmosphere. Let's talk about our favorite red sibling, Mars. The first noticeable change after a few hundred years would be your new skeleton. The gravity on Mars is much weaker than on Earth, so your muscles and bones would shrink. To make up for this difference, you'd have to eat more and probably start going to the gym. Also, you'd have to adapt to the low atmospheric pressure and colder temperatures. You need to retain heat, right? That means you'd need a thicker layer of body fat. Sorry folks, but on Mars, we might become fatter. Another reason to start working out. Another big change would occur in your skin. Your skin is like a big barrier that protects you from harmful things such as bacteria, UV light, looking totally creepy, and so on. So what would happen to it? Most likely, you would turn orange, due to the carotenoids. Carotenoids are a type of nutrient that you get from foods such as carrots, potatoes, tomatoes, and so on. They protect very well against ultraviolet radiation on Mars. They only have one downside. By eating a lot of pumpkins from the Martian farmers market, you'll gradually start to turn orange. But maybe it's not so bad. Maybe life on Jupiter would be easier. Yeah, no, it has no solid land. This planet is made up of hydrogen and helium and is referred to as a gas giant. You would simply float there, like in a huge cloud. And even if you managed to land and try to walk, it would be like moving through a super thick fog. So how would we evolve there? Firstly, we might become much larger in size to withstand the immense pressures. Secondly, the temperature fluctuations on Jupiter are enormous. The surface is terrifyingly cold and the temperature rises significantly under the outer layers of the atmosphere. Thirdly, if you lived on Jupiter, there would be no verbal language. This gas giant absorbs radio waves, so even if you were speaking, no one would hear you. There would be no music either, so no parties. And what's the point then? Hey, maybe we could communicate with sign language, but that's not so simple either. Jupiter is full of wild winds and storm clouds, so it's unlikely you would be able to see anything. So even if we evolved there in some way, our lives would still not be easy. Before landing on Saturn, you would probably want to check out its iconic rings, but you wouldn't be able to do that because Saturn's rings consist of a bunch of ice particles flying in space, so it would be extremely hard to land. So let's go straight to Saturn itself. At first, it may seem that Saturn is not bad for us. Some layers of this gas giant have quite pleasant temperatures. If we dive deeper into Saturn, it gets surprisingly warm, up to 26 degrees Fahrenheit in its second layer. This is an average temperature in countries like Sweden and Canada. But unfortunately, this is only one such layer. The rest of the planet is incredibly cold, so in order to survive on Saturn, we'd have to do a lot of work. In addition to the cold, we'd have to deal with the planet's harsh environment, including its intense storms, strong winds, and radiation. To protect ourselves from these conditions, we'd need to evolve tough skin, again, find some insulation, and so on. Next planet is Uranus. Uranus has a very different environment from Earth, with much colder temperatures, a lack of a solid surface, and a much different atmosphere. It's like another Jupiter, but with blue vibes. It's not that bad though. There's even water on Uranus. The only problem is, the planet is full of ammonia, that nasty stuff we use for cleaning, so don't be surprised if you feel the gross smell. Also, it's incredibly cold out there, almost like a never-ending winter. So what would it be like to survive in such a dark and harsh environment? We'd need thicker skin, again, to cope with extreme temperatures. And again, we'd need larger eyes to see better in all this darkness. We might even have to develop a new hearing system, like that of dolphins. Wouldn't that be fun? Let's move on to Neptune. If human beings were to evolve on Neptune, they would need to adapt to its harsh conditions. Neptune, the eighth and farthest planet from our Sun, is another gas giant. The only difference is this planet may have a solid core. If we were to live on Neptune, we'd need to float or swim in its methane-rich atmosphere. We'd also need to develop gills or something like that in order to breathe. Basically, we'd turn into space reptiles or cosmic fishes. The gravity on Neptune is slightly stronger than Earth's, but strong winds make it difficult to stand in one place. To withstand the wind, we need to be much heavier. Once again, you need to eat a lot and pump up some muscles. Yeah, technically it's not a planet, but we still love it and can't forget it. A small, distant, and incredibly cold world. Pluto's even smaller than our moon, and because of that, there's almost no gravity there. It will be extremely difficult to stand on it. To avoid accidentally flying into outer space while playing football, we need to create a fake gravity machine. And if we don't want to feel dizzy, we need to evolve a brand new nervous system. But Pluto isn't all that bad. For example, there's liquid water under the surface, and even some icy mountains. Maybe it would be possible to survive there if we had some serious equipment, clothes, supplies, and… nah, too much hassle. Anyway, from the scorching heat of Mercury to the freezing temperatures of Neptune, each planet has a unique set of environmental challenges and opportunities for evolution. While we may never truly know what humans would look like on these other worlds, it's exciting to consider the endless possibilities. Never stop looking at the stars and asking these questions. Have you ever wondered what it would be like if every planet in our solar system was the size of Earth? Well, it's time to dive into this mind-boggling scenario. Let's imagine what each planet would look like if they were as big as our beloved blue planet. Would the barren red landscape of Mars suddenly become a lush green oasis? Would the massive swirling gas giant Jupiter just disappear? And how would it affect our solar system as a whole? Are we all doomed? Buckle up and let's find out. The first planet on our list is Mercury, the smallest planet in our solar system. But now, forget about the moon-like Mercury. Instead, picture yourself on the surface of a super dynamic incandescent inferno. There are a lot of craters and active volcanoes around you, and right in front of you is a huge, blinding bright sun. What a nightmare! But let's break these changes down. Well, along with the size of Mercury, both its mass and gravity would increase. In that case, it's possible that Mercury would have more atmosphere. Temperatures on Mercury are extreme, not only because it's very close to the sun, but also because of its very thin atmosphere. So during the day, the temperatures there reach 800 degrees Fahrenheit, and at night, it becomes terrifyingly cold, down to negative 290 degrees Fahrenheit. But now, when the gravity is stronger, Mercury could have a denser atmosphere, so the heat would be better distributed across the planet. And the atmosphere isn't the only thing that could make it hotter. If Mercury became bigger, it would likely experience increased internal heating due to gravitational compression. And hypothetically, its tectonic activity could increase. In other words, more interesting landscape, more mountains, and more scary active volcanoes. Congratulations, you've turned Mercury into Venus 2.0. For us, all these changes wouldn't be very pleasant. Now it would become much harder to send our spacecraft there, so it's better for Mercury to stay as it is, small, calm, and boring. Basically, the complete opposite of our next planet, Venus. So what would happen to Venus if it was Earth-sized? Actually, nothing. It wouldn't change at all because Venus is already almost the size of Earth. It's even called the Earth's twin, although twin is a big word, of course. In reality, we couldn't be more different. Venus is often called the morning star because it's so bright and visible in the sky. But don't let its beauty fool you. This planet is one of the most inhospitable places in our solar system. Its surface is hotter than a freshly baked pizza, around 900 degrees Fahrenheit, and it's covered in thick clouds of sulfuric acid that would dissolve any human who tried to visit. So, unfortunately, you won't be planning any trips there anytime soon. So let's move on to a planet that, unlike Venus, could potentially become a new home for us, Mars. Picture yourself standing on Mars's surface, watching the blue sunset and breathing in a refreshing breeze of air. Yes, you read that right, air. Moreover, you could be surrounded by plants, animals, and basically feel like you're on Earth. But how is that possible? Bigger Mars would have a stronger magnetic field and gravity. This would lead to a richer and denser atmosphere. It would likely have a wider range of gases, including oxygen. Wouldn't that be cool? Also, a denser atmosphere could distribute heat across the planet, so Mars would become much warmer and cozier. And here comes the most important change: liquid water. Mars actually has some frozen water at its poles and in subsurface reservoirs. But with a stronger gravitational pull, it could potentially stabilize liquid water on its surface. Hooray! However, it's not all fun and games. New Mars would also have a volcanic personality. It's already geologically active, but now its internal heat and pressure would skyrocket. That means more frequent and more crazy volcanic eruptions. Imagine how exciting it would be to witness such eruptions on another planet, if you manage to escape the consequences. In general, the planet could become greener and lusher, but not safer, although it would still be great to see it. But it's time to move on to the giants of our solar system. And if we're enlarging the planets before, now it's time to squeeze them really, really hard. If Jupiter became 11 times smaller, oh boy, what a disaster that would be. The first thing we'd notice is a change in gravity. And I say we'd notice because now we'd have no choice but to move somewhere. Jupiter experiences from 30 to 100 collisions with large asteroids per year. No big deal, all because of its strongest gravity, which attracts them all and protects us. But now our big protective brother has turned into a small baby. Say hi to a bunch of asteroids. Oh, and say bye-bye to Jupiter. This planet is known for its thick, swirling atmosphere. But with a weaker gravitational pull, Jupiter would probably have a hard time holding on to it. So over time, it would slowly escape into space, leaving behind a thin atmosphere composed mainly of nitrogen and oxygen. We'll also have to bid farewell to the iconic appearance of another giant, Saturn. The most noticeable difference would be the disappearance of its famous rings. Made up of small particles of ice and rock, the rings are a unique feature of Saturn. But with Earth's gravity, they would either fall onto the planet or scatter into space. Bummer. Saturn is also a gas giant, just like Jupiter. Its atmosphere is made up of mostly hydrogen and helium. But if it were Earth-sized, its gases would be compressed due to the increased gravity. This would make it much denser. That means Saturn's overall size and shape would change. Theoretically, if we squeeze Saturn hard, it could potentially become a brown dwarf. It's a type of failed star that lacks the mass to sustain nuclear fusion, but emits heat and light. So, Saturn could stop being a planet altogether. The weather on it would probably have changed too. All its crazy storms, such as the famous hexagonal storm at its North Pole, would have become weaker and calmer. The next giant is Uranus. Let's try to compress this poor fella. First off, the surface gravity on Uranus would be much weaker than it is now. Its atmosphere might also change. If Uranus was smaller, it could have a thinner atmosphere and different gases altogether. This planet is pretty chilly, with an average temperature of -353 degrees Fahrenheit. Ugh. But if it was the size of Earth, it might actually warm up a bit due to its reduced volume to surface area ratio. Don't get too excited though, it would still be way colder than the coldest spots on Earth. As you can see, gas giants don't easily go through all this shrinking, except perhaps one of them. Surprisingly, small Neptune would become much friendlier. For starters, it would probably be a rocky planet with a tiny atmosphere. That means no more gas giant, but instead, a planet that's easier for humans and critters alike to live and move around on. Speaking of movement, because of the smaller size, the gravity on this new Neptune would be almost the same as Earth's, making it a heck of a lot easier to walk and jump around. No more floating away into space. Now, the atmosphere of the original Neptune is so thick you could barely see your hand in front of your face. And the surface pressure is about 100 times that of Earth's atmosphere. But our new Neptune would be much different, with a much thinner and less dense atmosphere. It would still have some methane, water, and ammonia in it, but nowhere near as much as before. Finally, the temperature. The current Neptune is freezing, with an average temperature of about -370 degrees Fahrenheit. But if it was the same size as Earth, it would likely be much warmer, just like Uranus. Ah, that's more like it. What a planet that would be. That's it for the changes in the planets. But what would happen to the entire solar system if we made all the planets so small? It's hard to predict, but it's clear that their gravity and orbits could change a lot. It's unlikely that any of them would have flown into outer space, or crashed into each other, or something like that. But many of their orbits would probably become quite unstable, and the number of collisions with asteroids would have increased significantly. Of course, all this is purely speculation. It's not like we can actually test all this. But it's still a pretty interesting thought experiment, and it makes you appreciate just how unique and special our solar system really is.